Hello, my friends. This is LeetCode 134 gas station. So there are n gas stations along a circular route where the amount of gas at the ith station is gas I. You have a car with an unlimited gas tank and a cost I of gas to travel from the I station to its next station. You begin the journey with an empty tank at one of the gas stations. So given two integer arrays, gas and cost, return the starting gas station's index if you can travel along the circuit once in a clockwise direction, otherwise -1. If there exists a solution, it's guaranteed to be unique. Okay? So this problem isn't too intuitive, so I'm going to try my best to explain it as well as illustrate it so you understand. Okay? I want to point something out before we start, right? Look at the constraints. Always do this, right? It's just good practice. Especially when you get to much harder problems like in LeetCode contests and stuff. Like this stuff is really important. You'll notice that the length of the arrays are the same, right? Meaning if there's the length of the gas array is 5, the cost one will be 5 as well, right? So we're not going to have weird edge cases in that regard, so that's good. Okay. This mumbo jumbo of words might be a little bit confusing to explain. So we're going to go to an illustration and I'll just explain it there. Okay. So it's basically, this is example 1. It's basically saying, right, so there's gas stations, right? Each gas, you can fill up a certain amount, but it also costs a certain amount to go to the next one, right? And it's basically saying, can you pick a starting point where you can go keep hopping, right? And remember, it's circular, so when you're at the last one, you have to go all the way back. Can you pick a particular index such that you can keep going, and then make it back to the starting point that you were at, right? And before we even go further, right, there is also one constraint in the problem, which is, if we can't travel in a circuit, we have to return -1. How do we know if we can't travel in a circuit? Well, the answer is really simple, right? If the total amount of gas is less than the total cost, right? Then we have a problem, because if the cost of hopping to the gas stations, if this entire array, the sum of it, is bigger than the total amount of gas we have, then at some point we're going to have a problem where we can't travel, right? And so we can't really complete a circuit. So we're just going to take the sum of the cost array, right, and the sum of the gas array. And if the sum of the gas array is less than the sum of the cost, then we have a problem when we return -1. That's how we handle the edge case, okay? Right? So basically, if the cost is if the cost of the gas array is bigger than the if the sum of the cost array is bigger than the sum of the gas array, we just return -1. That's kind of how we handle our edge case before we even do any code later, okay? So I just want to point that out, just point that edge case out. Now we can actually focus on only solving the actual problem at hand instead of that weird edge case where we return -1, okay? And so the way this problem is going to work is a little bit tricky. Like I said, I'll try and explain this as best I can. It's not that intuitive to explain or to see. The code's really simple though, so you'll kind of understand by the end, thankfully. It's not too complicated, the solution. So, again, what do we have to do here, right? Well, we have two arrays, right? A gas array and a cost array. And we have to find a particular starting point such that we can basically make a complete circuit and get back to that starting point. And then what we're returning is the index where that starting point is, right? And so we'll handle example 1 to kind of show how we're going to do this, right? So we have one gas in our car, right? Our little car, right? Right. And it costs 3 to hop, right? So this can never be our starting point because we only have one cost here, and we have one gas and the cost is 3. So our total output technically is -2. So we can never use this as our starting point. Index 0 here can never be our starting point. Well, let's look at index 1. Okay, we have 2 gas, but it also costs 4 to hop. That's not very good, right? Because our total output again is -2. So it costs more to hop over here than we have in the gas tank. Okay, what about here? Well, here again, -2, right? Okay, now here, right, 4. We have 4 in the tank, and it costs 1 to hop over, so we have 3 left over when we get here. Okay, that's good, right? We fill up 5, so we have 6, 7, 8. And it costs 2 to go here, and you can keep doing the math, but this is starting point here works out, right? And there's really 2 things I want you to keep in mind. Like I said, give me some grace. This problem is not too intuitive to explain, but I'm going to do my best here, okay, in terms of how we're going to solve this. Okay, like, there's really 2 things we need to keep in mind, right? Imagine we're going through our array with this being the starting point here, or even before that, right? Even before that. We know there must exist a solution here somewhere, right? One of these starting points has to be valid, right? How do we know that? Because we already handled our edge case where for -1, right? Meaning we already verified that the total cost, or sorry, that the total amount of gas we have available is greater than the sum of the cost, right? Because this would be, I mean, I guess I didn't actually explicitly do that, but this is example 1. You know, so there's a solution because you just look at it on the other page, but we'll do it here, right? So let's take the sum here. So we have 3, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. Okay, our sum of our gas is this, and here we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? Okay. So, that's another thing, right? When they're equal, that means there's a solution as well, okay? So technically, as long as our gas, or some of our gas is greater than or equals to the cost, it's fine, right? So I forgot to explain that. So if they're equal, that's fine as well. But there is one thing also you should keep in mind, which is that it says it's guaranteed to be unique. If there exists a solution, it's guaranteed to be unique. What does that mean? Like, imagine you have just some weird example, like 1, 1, 1, 1, 1, 1, right? Imagine these are little gas canisters here. Okay. Where is your starting point if this is a problem, right? Because technically all these could be valid starting points. Well, what this problem is telling you in the problem statement is that you'll never have a solution like this. Or you'll never have an input like this, so you don't have to worry about that, right? Because when it's telling you here, if there exists a solution, it's guaranteed to be unique. It's really just telling you that there's only going to be one starting point in the input they give you, right? Because in that example input I gave you, technically there's 3 starting points. You won't ever have that. You'll only have one starting input. Okay, and that's why I'm saying it's hard to intuitively explain or understand this problem, because there's just minute little details that you gotta keep in mind. Okay, so we know that the sum of the cost is not greater than the sum of the gas. So this is not the case. So we know that there exists one solution. Okay, so because we know there exists one solution, we know that one of these starting points has to be the index we want to return. That's number 1. Number 2 is we're starting at the start of the array and we're traversing all the way, right? So this is initially our starting point right here, right? We got a -2 overall, right? We can't hop over, right? So this is not our starting point. Then we go here, not our starting point because we got a -2. Here, not a starting point, right? When we start here, we made it to here, right? So we made it to the end of the array without any problems. So that means this has to be our starting point, right? That's what we want to return, this index right here. Why is that the case? Because again, we're going linearly through the array. So if we get to the end, right, without any issues, we know whatever our initial starting point is, and that will change over time depending if we get a negative, right? Because this won't be a starting point because it's negative, so we move over here. If we make it to the end of the array, whatever our starting point we came from, that's our solution, right? So our starting point is here. So we know that if we made it to here, this is our valid starting point. Because there's guaranteed to be one solution, right? And the ones after it, after the starting point, haven't given us any problems. So by the time we get to the end, we know that this is our starting point, right? And it won't be any of the ones before. And it won't be any of the ones after either. It won't be any of the ones before because obviously we move forward for our starting point, and it won't be any of the ones after because if it was, I mean, we would have had a negative number, and we would have moved our starting point forward, okay? So yeah, that's basically the two things you got to keep in mind, the two big things of how we're going to solve this problem. And yeah, this problem is really, it's the solution will make a lot of sense, but it's really complicated to explain. Okay, so let's do this. So we have a -2 here, right? So this is not our starting point. -2 here, not our starting point. -2 here, not our starting point. Okay, when we go here, we have a 3, right? So this is our valid, so new starting point. We're going to hop over here, right? We add 3 to the 5. We have an excess, right? Then we subtract 2, and whatever that number is will be positive. And then you can loop around and do the math if you want. But you'll see that this is our starting point. And what index is this? 0, 1, 2, index 3. And if we go to example 1, it should be 3, okay? Now let's go to example 2. I don't even know what the solution is. Or the output should be, but we're just going to do this to show you that this will work. Okay, so 2 minus 3 gives us -1. This cannot be our starting point, right? So we're going to go here. This will be our new starting point. 3 minus 4, that's negative. That cannot be our starting point. And then we'll go here. 4 minus 3, that is a 1, and we made it to the end of the array. So this is our starting point, right? We can basically, I mean, if you want, you can do the math. I'll just do it really quick because this is a very short example, right? We have an excess of 1. When we loop around, we add 2, so we have 3. 3 minus 3 is 0, right? So technically we can hop over, but we have nothing in the gas tank now. Let's add 3. We have a 3. 3 minus 4 is -1, so we cannot hop over. Oh, right. Yeah, so when we get to here, it's -1, so we actually can't come back over here, so we don't have a valid solution. But even before that, we should know we don't have a valid solution, right? Because the sum of this is 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9, 10. Right, I didn't check that, my bad. But in our code, we'll check that, right? The sum of the cost here is bigger than the sum of the gas. So we know for sure there's not even a valid solution. We didn't even technically need to check anything here. In our code, we won't even check any of this stuff because we will hit our edge case, right? So anyways, that's pretty much it conceptually and visually. So I hope it will make sense to you. The code, I swear, it's way simpler and it'll make so much more sense. But I hope my explanation and illustrations helped. Okay, now we're going to go back into the code. All right, we're here back in C++. So, first of all, let's check the edge case, right? Remember what the edge case is? If you don't, I'll explain it, right? We're basically going to check if no solution exists, right? And the way we do that is basically if our total gas available is less than the cost. And again, these are just the sums of the array that I'm talking about here. If that's the case, then we have no solution and we have to return -1, right? And the way we're going to do that in C++ is we're going to say accumulate gas.begin, gas.end 0 less than accumulate gas.begin, gas.end 0, right? Here we're just going to return -1, right? Just an edge case we need to handle, right? I'll just write this here just to make sure it's easier to keep along. I'm just going to add important constraints to keep in mind, just to make you understand this problem a little bit easier, which is that the array lengths are going to be the same. So it makes our life way easier, right? And there's also one unique solution, right? So we know that there is a solution because if there wasn't, right, we would hit this edge case up here. So we know that there is one starting point. So we know there's a solution, right? So we need to return that. We're just going to call it the resulting index, right? You can call it the starting index if you want. Maybe result index isn't the best variable name, but it's up to you. The result index, we're going to turn that down here, okay? Now, we need another variable called total, and total is basically just how much gas we have in the car at any point, right? Because if we have a negative number, it means that our costs have exceeded the amount that we have put in the gas so far. So for example, if we have 4 in the gas and we waste 3 to move to the next station, that's fine. But if we have like 3 in the gas tank and we waste like 5, well, that starting point is not valid. So we need to shift our starting point to another index, right? And this result index variable is basically where our starting index is going to be, right? If we can make it to the end of the array, we know that's our solution, right? And if not, then we have to shift our starting index, which I'm just calling result index in this code, right? So remember, we're just going to start at the start of the array and move towards the end, right? That's what we're doing. So we're going to say int I, right? Just a simple for loop. These array sizes are the same. You can use gas, cost. I mean, you should use gas just for some, because it makes the most logical sense, but it doesn't really matter. So again, what do we add to this total? We're just taking how much gas did we put in the tank and subtract how much did we use up to go to the next station, right? Just like that. Now, if at any point the total is negative, we have an issue. And what do we need to do? We need to set total back to 0 because we're going to have to get a new starting position to complete the circuit. And our actual starting position, let's make sure we actually set that to I plus 1. We're currently at the index I, and that's why we're doing result index as I plus 1, right? Because we're shifting our starting point to I plus 1. Okay, and again, our total is getting set to 0 because that's going to be our new starting point. And then I believe that's actually it. That's our code. Like, it's really not too complicated. Oh, I forgot my semicolon. That's not good. Okay, I think this should submit. I don't have any errors, I don't think. Okay, that's it. So yeah, this problem isn't too hard. Like, it's just, it is not that intuitive. I'll see if I can zoom in. I don't know. Sometimes people say my videos aren't that, it's hard to read sometimes. I get that. I'm just used to having my zoom at 100% or whatever. But anyways, I hope this helped, and I'll see you in the next one. So yeah, peace out.